I move on is an enzyme. As you can see in this intro, what an enzyme does is they're chemical reactions inside of your body that make things go faster. So pretty much if you don't have enzymes in your body, you could not live. Like there's most of the chemical reactions that go on are very slow and you need them to be fast. So that's what an enzyme is. It's just like the basic definition. Also, I'm kind of reading from here. So what's important about an enzyme is they operate at optimal temperatures. So if it's too cold, the enzyme will not be able to survive and work. And if it's too hot in its environment, an enzyme will denature and die. So too cold, you die. Too hot, you die. So this experiment is just showing, I'm going to pick different temperatures and show you all the optimal enzyme activity. So as you can see right here, I put 1 degree Celsius, which is cold because freezing is 0 degrees Celsius. And the enzyme activity is very low. But then as I move up in temperature, what can you expect to happen? The enzyme activity will become greater. So let me do that. What's tough is this experiment goes in Celsius, and most people I'm finding out aren't very good in Celsius. So 0 degrees Celsius is freezing cold, right? But 25 degrees Celsius, anyone know? What? Close. A little lower. Room temperature. So 25 degrees Celsius is room temperature. 37 is body. Yeah, 37 degrees Celsius is body. So I'm going to go ahead and type in 10 degrees Celsius just to give you all a good graph. Gets a little better. Now we're going to raise it to room temp. Gets not much better. That's because I typed the same number. So room temperature, enzyme activity goes up. So now I'm going to put in 37 degrees Celsius. And what do you think will happen if I put a human enzyme at 37 degrees Celsius? It's going to work at its best optimal temperature because your enzymes in your body are meant to work at body temperature. That's why whenever you run a fever, it can be really dangerous because if your body gets too hot, it'll kill your enzymes and then you die. Same if you get too cold. So 37 degrees, boom. So what do you think will happen if I type in 50 degrees Celsius? It's too hot, so it'll denature. It's going to die. Boom. That was like a really big death. So y'all get the concept I'm trying to make. That's really just the take home. This is not a fantastic graph. Ideally, you'd want it more like a bell curve. Yeah.
What dies?
The enzyme.
You do.
The enzyme.
Yeah,
Okay.
sorry.
The enzyme and you.
You and the enzyme?
Yeah, if your enzyme dies, you die.
Yeah, so enzymes need to be at the right temperature to work.
So is this the graph right here?
This is a graph. Don't put background on this graph because this is really horrible. But I'm not going to take the time to make it like a nice bell curve. But in statistics, you want, a nice bell curve. But you get the idea. So if you just post this, or if you want to recreate the graph yourself, I don't care if you want to just copy and paste it.
This is.
It cracks me up because when I get papers from people in the back, it's like this whole, like the whole room.